A scalar is simply a number that is outside the brackets of a matrix and that is supposed to multiply by all the elements in the matrix. We have an example here. So in this case, given matrix A as this one here, we have to find 3A and then negative 2A and half A. So in these instances, 3, negative 2, and negative half are scalars. Now, starting with the first one, 3A, it simply means you take this matrix A, multiply every element in it by 3. So we have done it here. 3A is equal to 3 into the matrix of A, which has been given up here. So what we do, we take this 3 and multiply by all the elements in this matrix. 3 times negative 1, then 3 times 4, 3 times 8, and 3 times 11. So if you simplify that, you will get this times this being equal to negative 3. Then the next one, 3 by 4 giving us 12, 3 by 8 giving us 24, and 3 by 11 giving us 33. Now, for the second question, we have negative 2a. We do it in the same manner. We take negative 2 times the matrix A, which has been given here. So we shall have negative 2 times each of the elements in this matrix. Negative 2 times negative 1. Then negative 2 times 4. Then negative 2 times 8. And then negative 2 times 11, which when you simplify, you'll get the first one giving us 2, negative 8, negative 16, and negative 22. For Roman 3, the third question, we are supposed to get negative half of matrix A. So you take that negative half and multiply it by the elements of matrix A. So negative half times negative 1, then negative half times 4, negative half times 8, and negative half times 11. Now, when we are dealing with matrix, we always prefer using a decimal instead of a fraction. That's why I have converted this negative half into a decimal as negative 0.5 and multiplied by all the elements of the matrix. So that simplifies to the answer that we have there. Negative 0.5 times negative 1 gives us 0.5. Negative 0.5 times 4 gives us negative 2. This one gives us negative 4. And this one negative 5.5. So that's how we multiply a matrix by a scalar. Multiplication of a matrix by another matrix. We have been given matrix A and matrix B. We are supposed to find AB, and we are also supposed to find BA. So the first thing to do for us to solve this first question is to test for compatibility. That means we deduce whether it is possible for us to multiply these matrices A by B. How do we do that? We take this matrix, we write it here, then we write this other one second, like this. After that, we establish their order. The order of a matrix simply represents the number of rows and the number of columns of that matrix. Like in this case, matrix A has 1, 2 rows and 1, 2, 3 columns. Therefore, it is of order 2 by 3 because there's 2 rows and 3 columns. Similarly, this one has 1, 2, 3 columns, 3 rows. That's why we have 3 here by 1, 2 columns. So that's why we have these 2 here. It has 3 rows and 2 columns, and that's why it's of order 3 by 2. Now, matrices can be multiplied if the number of columns of the first matrix are equal to the number of rows of the second matrix. If they are equal, then you can multiply them. Like in this case, they are equal, therefore we can multiply them. Now the remaining numbers, which is 2 representing the number of rows of this matrix, and this one representing the number of columns of this matrix, will give us a prediction of the order of the answer or the product. So that means that the product will be a matrix of order 2 by 2. A matrix of order 2 by 2 takes this format. So it will have 2 rows, 1, 2, and 2 columns, 1, 2. Now, if we label these elements here, we shall have them like that. That one is occupying row 1, column 1. That one is occupying row 1, column 2. And this one is occupying row 2, column 1. And this one is occupying row 2, column 2. Now, this is important because it gives us a guideline on which row of the first matrix you should multiply by which column in the next from the next matrix, the second matrix, to arrive at the element to write in that position. So for us to multiply A and B, we write them as indicated here, and then this element, because it's in row 1, column 1, means we shall take the elements in row 1 in the first matrix times the elements in column 1 in the second matrix. So that's what we have done there. You can see we have 0 times 6 plus 1 times 8 plus 2 times 10. Next, to get the element here, because it's in row 1, column 2, it's in row 1, column 2, it means we shall take the elements in row 1 from the first matrix, or in the first matrix, times the elements in column 2 in this second matrix. The product is the one we shall write here, and that's what I've done there. You can see we have taken 0 times 7 plus 1 times 9 plus 2 times 11. Now for this one, this element is in row 2, column 1, as indicated here. So we shall take row 2 times column 1. So we shall have 3 times 6 plus 4 times 8 times plus 5 times 10. So we have it there, 3 times 6 plus 4 times 8 plus 5 times 10. The last one here will be gotten by taking row 2 times column 2, meaning this row times this column. So we shall have 3 times 7 plus 4 times 9 plus 5 times 11. And that is what is given there. So after that, then you simplify. 0 times 6 is 0, plus 1 times 8 is 8, plus 2 times 10 is 20. So this gives us 28. So if you work out the rest, you will get this one giving you that one, and the other 100, and the last one will give you 101. So that is how we multiply a matrix by another matrix. Now, the second question wanted us to find BA. So we write matrix B first, and then we write A. The order for this matrix B is 3 by 2 because it has 3 rows, 1, 2, 3, and 2 columns. And then this one is of order 2 by 3 because it has 2 rows and 3 columns. Now, looking at the number of columns for the first matrix and the number of rows for the second matrix, the numbers are the same, they are equal, and therefore we can multiply the matrices. That means the answer will have 3 rows and 3 columns. So it will take this format here. We can see we have 1, 2, 3 rows and 1, 2, 3 columns. So we start multiplying. This element is in row 1, column 1. So that means take the elements in row 1 times the corresponding elements in column 1. And that's what I've done. There you have 6 times 0 plus 3 times 7, giving us 21, of course. And this one is in row 1, column 2. It means you'll multiply the elements of row 1 times the corresponding elements in column 2, because this is an element in row 1, column 2. And when you multiply that, you will have 6 times 1 plus 7 times 4. Then this one is in row 1, column 3, meaning we shall multiply elements in row 1 times column 3, and that gives you that result. The element here is in row 2, column 1, meaning we shall take row 2 times column 1. 8 times 0 plus 9 times 3, like that. Then this one is in row 2, column 2, meaning we take row 2 times column 2. And then the next one is that one, because it is an element in row 2, column 3, meaning we shall take elements in row 2 times the corresponding elements in column 3. Now, this one is the next one. It is in row 3, column 1, meaning we multiply these elements in row 3 times the corresponding elements in column 1. That gives us that result. And then this one is in row 3, column 2, meaning we multiply row 3 times column 2, giving that. And the last one, of course, is that one, which is courtesy of multiplying row 3 times column 3. So if you simplify these values here, you will get the answers being that one for the first one, that one, this one gives us this, and then this one will give us that, then this one will give us the element here, and then the rest will also be gotten in a similar manner like that. So that is how you multiply matrices, and specifically that's how we do BA. Now you realize from the example, the two examples we have here, or the two workings we have done, that the answer you get when you multiply matrix A by B is not the answer that you get when you start writing B and then you multiply by matrix A.